Hi guys, welcome to this talk about integration testing. I hope the lunch won't be too heavy on you. So I will try to keep this as entertaining as possible. And this is my first time in Latvia, so a little introduction is in order. I'm Nicolas Frankel. I'm a Java developer, architect, solution architect, well, whatever the customer wants me to do because I'm a consultant. I've been doing consulting all of my life. Right now, I'm working for Hybris, which now has been bought by SAP. Hybris is an e-commerce platform based on Java and Spring. So today I'm here to talk about integration testing, and why I'm here because last year I released the first version of the book. So this is a reason because I found that you found much documentation on unit testing and unit test and how you should do that and that and that and that. And integration testing is much more complex. There are a lot more stuff to understand, and it might be contextual. So, okay. So let's start. Some generalities first. You know there are many kinds of testing. Of course, everyone knows about unit testing. You got mutation testing, grid testing, performance testing. At some point, I stumbled upon a page that listed nearly 100 different kind of testings. In this talk, I will just restrict myself to unit and integration testing, and it will be enough, believe me. So you know that the definition of unit testing is testing of a unit in isolation. So you try to isolate the class and you test it. So you give input, you check the output, and thus you can check the behavior. Integration testing, in contrast, is just testing the collaboration of multiple units. So I like pragmatic stuff, so let's take a prototype core. Unit testing would be like you would test every nut and bolt separately, making sure that every one of them is to your specification. And integration testing would be like going on a test drive. So this is the first stuff that I should mention, is that unit and integration testing should not be exclusive. That you can see people on the web saying, hey, but guys, integration testing is very expensive. Just do unit testing. It's not enough. And likewise, you see that, oh, but unit testing takes a lot of time. You should do only integration testing. Also, that's not true, because probably if you were the product manager of the car, you wouldn't go on a test drive without having tested the pieces separately, because if it fails, then probably it would cost too much, right? So you should do one with the other. Okay, when you do integration testing, there is one thing that appears, a new concept that is not part of unit testing, is the concept of system under test. And system under test is a part of the whole. So by unit testing, the system under test is a class, and yeah, it's implicit that it's only a class, so you don't talk about it. But with integration testing, first, you should define what should get tested. And as you can see, it can be the whole system or just a small part of it. In this case, if you test just a small part, then you can use the same methods as normal unit testing, so you can use dependency injection and test doubles. So you can reuse the same ways as for unit testing. Something important. Testing is not about having the highest code coverage or doing better than your colleagues and stuff like that. You test because you save money in the long run. So it's about return over investment. And what I noticed is that the larger the system under test, the more fragile it is. And so the less the return over investment is. So you should probably organize your integration tests in a pyramidal way. Like the larger the system under test at the top and unit test at the bottom, and you have many, many, many more unit tests than integration tests. Also, what you probably should strive to do, not to test too many error cases in integration tests. You should only null way. Should I remove the mic or not? No? Okay. So yeah, just test about really the standard case. Integration testing brings some interesting issues that do not appear in unit testing. The first is integration tests are slow. How many of you do integration testing so far? About half the room. Okay, great. So for me, my experience is that they are slow. They are more fragile, and they are harder to diagnose. So let's see how we can try to ease each of the issues. So why are they slow? Probably because they are dependent on something which is not only code, like a database, like file system, like anything, or a container, like Spring Container, like Tomcat, anything, any application server. So how do you cope with that? You separate integration tests from unit tests. Of course, that won't make them faster, but at least you will first fail your unit test. That means you will fail fast. That means that's good, because then you can recover from them faster. That's one of the reasons why you don't want to only have integration tests, because they are quite slow and because they fail in a very slow way, so that it really slows down your feedback loop. So you separate integration tests from unit tests. And it really depends on the bit tool, right? Who is using Ant? Lucky guys. Who is using Maven? Great. And Gradle? Oh, guys, come on. It's not so hype anymore. Okay, I will just keep myself to Maven in this case. So just a reminder, this is the Maven lifecycle, and you know there are phases. Each of one has to be run in a sequence, and at each phase you might attach, or some plugins might already be attached, like for example when you compile, then you will call compiler.compile. When you test, you will call surefire.test and stuff like that. And you see that in the Maven lifecycle, there are already 4 phases meant to be bound to integration testing plugins. So you've got pre-integration test, integration test, post, and verify. That's very interesting. And on the unit test side, there is only one. So why is so? So you know that when you execute Maven test, you execute the Surefire plugin, which is by default implicitly bound to the test phase. And by default, it will run every test case that ends with test, starts with test, or ends with test case. So what the Maven guys did, they copied it just stupidly, and they changed the default. Like now, you have an integration test by default if it ends with IT, starts with IT, or ends with IT case. So that's very easy to separate them. How does the Maven failsafe plugin works? Well, as I told you, you have 4 different phases. So you can prepare, like start up the container in the pre-integration test. You can run your test in your integration test. You can shut down the container in the post-integration test. And then you can fail your build in the verify phase. So that's the most important stuff. Just don't forget that in the integration test, you don't verify because probably you want to clean up your resource in post-integration test. So you fail your build in verify. The real difference also comes from that it's not automatically bound. You have to bind it explicitly. So if you have a POM, probably if you use Maven, you have one, that means that you can just stupidly copy-paste this snippet. And as you can see, integration test is a goal, it's also the phase. Verify is a goal, it's also the phase. Very stupid. And this way, every time you run MVN verify, then first it will try the unit tests, fail them, perhaps, and if it runs correctly, then it will run integration test afterwards, provided you name them accordingly. So once you are at this point, continuous integration is very easy because you can continue running your MVN test at every commit. So very, very quick feedback loop. And then have your integration tests that run much slower depending on your context, daily, hourly, or whatever. So that was a problem about speed. Now the problem about fragility. And yeah, integration tests are fragile by nature, probably because they are dependent on external resources. And there are a lot of external resources that you might use in integration testing. Something that you might not even think of, that, yeah, the file system is a resource. Time might be a resource depending on your use case. If you want to check that a batch starts at a definite time, you better test it really, not in production. Common and widespread resources are databases, web services, FTP servers, MOMs, whatever. There are a lot. And just two examples, very simple example. How do you cope with fragility when you use time or file system? Again, use dependency injection, use abstraction. If since starting from Java 7, don't use java.util.file anymore, use the path. This is an abstraction. It can be easily mocked. It's not bound to the file system. So this can be tested very easily. Second, how do you cope with fragility with database? So if you haven't done any unit testing before, you can inject a mock DAO into your service, a mock repository, then test your service. Works quite well. Then you can really isolate. But how do you isolate your DAO from the database? Would you mock the database? It doesn't make any sense. So in this case, what you do is you use fakes. So you know what fakes are? Fakes are real components that are not used in production environments. So they have the same behavior, but they are more under your control. So for example, if we take the Oracle database, who uses Oracle in production? Not so many people anymore. Right, that's good. That might change. Okay, anyway, taking this use case as an example, you can use Oracle Express that you have to install on the machine, so either your own machine or the continuous integration server. You might use in-memory database. The thing is, whatever you use, you really want to close the gap as much as possible with the production system. So the best way to do that is to use the real database and use a dedicated schema, even better one for each developer. And that works pretty well. Probably your DBA will hate you because, yeah, it will take a lot of space, but it's still the best option if you really want to reduce the risk to a minimum. The closer you are to the real infrastructure, the smaller the gap is, then the harder it is to set up. If you are using an in-memory database and you can manage it inside your code, it's quite easy. But if you want to use a schema, a dedicated schema, probably you will have to configure stuff in your code and in your Maven POM to do that. Just for the record, if you want to close the gap but still use a memory database, there is H2, which has a compatibility mode with Oracle. So of course, it won't be the real infrastructure, it will be a memory database, but at least you will try to close the gap while still being very, very fast. Another problem comes from web services. Web services are now everywhere. You're probably dependent on web services, or you're probably offering web services yourself in your application. So you might think, okay, I might divide the web services into a typology of those that I am hosting and those that I'm not hosting. But in this case, it will be much easier if you think about the technology stack underneath. So let's divide the world into REST web services and SOAP web services. How do we cope with that? Same techniques. We use fakes. And in this case, since we don't have such already made fakes, we make the fakes ourselves. So for RESTful web services, we can use small micro web frameworks. Spark is one, there are other, and basically Spark is just very easy to set up, and in this case, you just can serve static JSON file. So here you can see a snippet of a Spark application. So we set the port. This can be set to whatever you want, and you can see that when the DSL is quite easy to read. So when I receive the request hello, then I will return a string. When I receive the request /user /something, then I can use /something to return it. And I can also change the response. But again, the easier would be to just create a static JSON file and serve it. Try not to be too smart when you're doing this kind of fakes. So faking REST services is quite easy. Who is still stuck on SOAP web services? Who is doing enterprise stuff? Oh, if I wait till a little more hands will get up. Okay, so I'm sorry for you, but doing SOAP faking can be done with Spark, but it will be much, much, much harder. In fact, probably faking web services, SOAP web services is really cost expensive. But anyway, it's possible. But in this case, you might want to use a dedicated tool. Who knows about SoapUI? Great. So SoapUI has this dedicated guy, and you can use it to create your what they call mock, but in this case, it's more fake web services. And it has a very great documentation. It understands many SOAP standards, authentication, headers, what have you. And it's really a great tool. So how would you use it? Then you would get the WSDL, the WSDL. You would create the mock service. Will create the response that you want to fake, run the service, and then just use the code and put the dependency to your local host. Now the problem with that is, okay, how do we get the response? You don't craft it yourself. Probably you use a real web service, get it, and then copy it and customize it a little. The second problem is, and the most problematic, is how do you run it? Because what I told you is, it has a guy and you have to do that and that, this very manual task. The good thing is SoapUI, and not many people know this, has an API. So you can get the drawer and hack it around. Of course, as I told you, it's not that easy, but it's possible. So if you really, really want to have your stuff faked and your integration test running, it's possible. Here you can see that I get the WSDL, and here I create everything myself. And here, instead of writing the soft envelope myself, probably, as in Spark, I will just download the response, craft it, and put it somewhere in my test resource folder to be reused. Otherwise, it's too hard. How do you do that in real life? Well, again, keep things simple. If it's too complex, probably it has no return over investment. So either you are running a software which must have 100% quality, then it's worth it. If not, think about the consequences. Think about the cost that you have to put into it before running into the sync. And also something you probably heard, that it's bad to duplicate code, and that in tests, I would advise you not to try to be smart. Just if you need to duplicate code, duplicate it. It's not very important. What is more important is if the test fails, probably what people will do is they will read the test. And they have to look in other places to understand what the test does. Probably it's a bad test, especially for integration testing. So probably what you would like to do is have everything into the same file. Just an advice. So far, we have talked about simple dependencies. So we have talked about collaboration between classes. We have talked about external dependencies, but we forget the most important dependency. And the most important dependency is a container. Because you can integration test whatever you want. If you fail to configure your Spring container, it will fail. So that is very important. So how do you test, for example, the Spring configuration? You probably have to run the Spring application itself. That's good because Spring is really, really, really great at testing itself. But you have to take care in your design of your configuration files. If you don't integration test, you can put everything into the same configuration file. That's okay. But if you want to integration test, you want to be able to replace some beans with fake beans. And in this case, you need to decouple, you need to fragment your configuration file. So the simplest stuff is the data source configuration. So here I have my service, I have my repository, and in my repository, I say that I will inject a bean of type of ID data source, sorry. And then this is one single configuration. And here I have two different fragments. One will be for production, like it will be a GNDI lookup. And here for my test configuration, it will be a simple bean using whatever data source you want, so long as it has a contract of data source. And then this is how it translates. This is my production fragment, and this is my test fragment. And here you can see that I'm using simple H2 driver. So that is quite easy to test afterwards because this database is under my control. I can do whatever I want with it. Just here, notice the one, and let's go back to this one into a few slides. These fragments can be set into your project folder like so. The main configuration will be here, and in the test resources data source config, I will use my H2 database. Here, I will use the GNDI lookup. And because of how Maven manages the class path, when you run your test, this one will be used. When you run your production stuff, this one will be used. And it can be done exactly like so, or with a small customization with Java config, because Java config, is the thing to use nowadays. If you want to do integration testing like this, if you want to decouple your fragments, first thing is you don't want to reference fragments inside fragments. What you want is to have either your test or your production application referencing every fragment and letting Spring assemble everything. That prevents at some point that you want to reuse a fragment, but it's bound to another fragment that you don't want to have and stuff like that. So just let the topmost component assemble configuration file. Second tip is how many times did it happen that you used a framework and with big project generally, everything went nicely, and then in production at some point you had exhausted your pool of connections because someone forgot to close the connection. Maybe it happened a few times, not so many times, like 10 hands. In integration testing, this can be tested. You just set the maximum number of connections to 1, like I showed you previously. And then you are sure that if you have a pull exhaustion, then it will be tested very, very fast. You will fail fast. And last tip that has nothing to do with integration testing, use Java configuration instead of XML. Who uses the Spring framework? Or not so many people. Who uses plain Java EE stuff? Not so. What are you using, guys? No containers? So, can someone tell me what he's using? Scala, okay. And you have no container, you just run like that, play framework. Okay. Okay, Scala, what else? You are shy or you are sleeping. I see already 2 people sleeping. Okay. I'm sorry, because then I thought that Spring was much more used. So bear with me, I will talk a little more about Spring. So test with Spring, and good news that Spring has something called a Spring test module, and it's quite easy to use. Basically, class pass, and let's talk about TestNG, but you have the same stuff with, you can just extend, oh, sorry about that. You can just extend, yeah, and people who like dissing out Spring will probably be very happy there, because you have to extend abstract, transactional, test, ng, Spring context test. Yeah, it's long, but if you're using an IDE, it will be much easier. And then you can, using the context configuration, tell this class to assemble the fragments that you want to use, and only those fragments. And in the test class, if you want to mock out a behavior or check how a bean reacts, you can inject any bean into your test class. So very easy. In this snippet, like here, I will be using main cfg.class and another cfg.class as configuration classes. As I told you, I extend abstract stng stuff, and I auto-wire, or I inject the order service, so I can call method on that, and I can assert whatever I want, perhaps by injecting other beans. Stuff that can go wrong with Spring are the database transactions. And transactions are generally bound to business feature, like when you do a credit card transaction, when you want to transfer money. So they are implemented on the service layer using the transactional annotation. The problem, or not so the problem, is Spring designers were trying to be smart. So when after the test, the transaction is rolled back. And yeah, it means, okay, we didn't touch the data, it's great. But actually, we don't want to test into the production database. We want to test on our own schema, on our own database. So I want the data to be persisted, if only because I really, really need that it goes wrong to check the state of the database. That's very stupid, but very important. And by default, it rollbacks the transaction. So what you should do is to use a transaction configuration and set default rollback equal false. Of course, it's still possible to still roll back some transactions by putting rollback true in a simple method. Here, this method won't be rollback, and this method will be rollback, but because I overwrite the rollback default behavior. So it's still possible, you have to think about that. Now comes the Java EE world. And the problem with the Java EE world is that you only have auto-wiring. When you inject something, you are not explicit. You are implicit. When you inject something, you are asking CDI to just get me the unique bean, the unique object with this interface, and inject it there. As you know, with Spring, and I'm more in favor of that, you can have that, which is not so nice, or you can have explicit. You say, I want this bean, and I inject them in the constructor. With Java EE, it's not possible. The second problem with Java EE is you might have different application servers. I mean, that's the point of Java EE, that you have a single application, but then it can run on any Java EE compliant server. Who thinks this is just bullshit? Yeah, me also. I had to migrate a standard Java EE application 8 years ago because it ran on Oracle server or C4G server, and we wanted it to run on WebSphere, and we had to change stuff because it just didn't work. So this is just bullshit, but still, it's a nice idea, and mainly it works until it doesn't. So you have two challenges. The first is, how can you isolate a system under test? And the second is, how can you test on different application servers? And for defining your system under test, since you cannot choose which bean, you will only deploy the classes that you want. And there is something called Shrinkwrap, which is part of a bigger project called Archelion that I will describe in a few slides. And this Shrinkwrap stuff has an API that lets you create, assemble the jar, the war, the ER that you want using a simple DSL. So this is quite great. And it has Maven integration, and Gradle too, but I shouldn't say it out too loud. That, for example, if you are dependent on libraries, right, you don't only want to deploy your own classes, because you also need to deploy libraries. And it would be very, very stupid to redeclare your libraries into the Archelion test. So Maven integration makes it possible to just read the POM and take the libraries that you want. So here is a simple snippet. It looks very big, but it's not so big. So here you declare the place where you want to get your resource, and it's a static Fluent DSL. So Shrinkwrap is a start. You will create a web archive. So here you said that you will want to create a war. You name it mywar.war. You add this class. You add every class that is under this package. Then you will add into the webin folder the persistence.xml, and it has to, the persistence.xml. It has to be put into this folder. You can do it like that. Likewise, with the webinf page myGSP. And here you can put it as a root of the folder. So this one will be accessible, the JavaScript. And don't forget to use the web XML that you want, and you're done. So this is a simple DSL that lets you pick and choose whatever resources you need. And it works quite well. And of course, I told you about the libs. So here you can get the libs from the POM. You will take every dependency that had scope, compile, or runtime. You will get them. And don't forget to get the transitivity and add it as in your WAR file. So you will use this additional line in the previous snippet. So again, this can make you able to create very small deployment package or the biggest one with no problem. And with that, you can deploy exactly what you want, and you can CDI however you want. The second problem with Java EE, as I told you, is you must be able to run on different application servers. This is perhaps not so important, I think, at least, to do that when you are a simple application developer. But if you are a product developer that you want to give or UI or AIR, and you are guaranteed that it works on every application server, It's like when you're deploying an Android application, you want to make sure that it works on every device, and you want to test it before. So Archillion is provided by Red Hat, and it's an abstraction layer to download, deploy, and test application. And basically, since it's an abstraction layer, you don't deal with the application servers themselves. You need container adapters, and of course, those container adapters have to be existing for your application server. To be honest, there are a lot. There are some that I don't listen, like Tomcat, for example. There is a simple Tomcat container adapter, because you might want to run your not so compatible Java EE application just on Tomcat, just to check if it runs. And it's fully integrated with Maven. Again, with TestNG, because I prefer TestNG to do JUnit, because JUnit in the name sounds like unit testing. Or when we are doing integration testing, it's better to use TestNG. As a word of advice, use TestNG, because it has a nifty stuff that doesn't exist in JUnit, and this stuff is test method ordering, test method dependency. A simple use case is, imagine that you have a checkout scenario. You are running an e-commerce shop, and you have different steps. Like first, I want to log in, then I want to add stuff into my basket, then I want to check out the basket, then I want to pay, right? And in a JUnit scenario, it will be very hard. You will have everything into the same test method, and if the test fails, then you will have to look at which line it failed. With TestNG, what you can do is have a dedicated method for each of those steps, and then make each step dependent on the previous one. And TestNG will execute them in order, and when one of them fails, then you will at least see the name of the step which failed. So for integration testing, think about TestNG over JUnit. Who here uses JUnit and TestNG? Oh, you are a hero. Great, one person. So for all other people who are not asleep, then I would advise them to check TestNG. It's still maintained. It didn't die. Yes, this is our Archillion test, and because we are using TestNG, there is no runner, so we have to extend Archillion. Like Spring stuff, we can inject whatever you want. Here we have a specific method, static, and you can name it however you want. The thing is, this will be the one who will be called by the Archillion framework. Here, you should create your Shrinkwrap archive. So remember Shrinkwrap here? So this is the code that should be placed here. Here, it should be web archive, because in the previous slide, I showed you web archive. And here, it's exactly the same as Spring stuff. You have the test method, and you test your stuff. So you inject it, you use it. So it's quite similar. The only difference is, in this case, you need to create the Shrinkwrap archive. And this is an example Archillion configuration file. And here in this Archillion file, you will see all containers, in this case it's only Tommy, that I will use for my tests. And depending on each container, you might want to configure it in a certain way. So here, for example, I tell Archillion to use for Tommy any HTTP port. So by using that, and in conjunction with the previous slide, when I run my integration test, Archillion will download Tommy, start it, run the test on Tommy, and stop it afterwards. And so in this case, you will do everything in container. And this is the highest test that you can do. So I am nearly finished. I want to point out that it creates noise when you drink. I just want to point out I want really to focus, to emphasize that integration testing, unit testing, whatever testing you do, is really because you want to save money in the long run. I see many people who try to have the highest possible code coverage just because it's so nice on the dashboard. No, really, it's useless. At some point, it's called overquality. Before, people didn't test enough. Now I think that people test too much. What you really want is to save money in the long run. So please, think about that. So here you can have the URL of my book. You can follow me on Twitter, become my friend on LinkedIn. And now is time for some Q&A, if you have any, at least for the people who didn't fall asleep.
Wait, please. Excuse me, could you please wait?
Which one, the SOAP or the REST? So the REST, in fact, it's not a framework to do fake web services. You can use it to do your real web applications.
Yeah. Just give me the name again.
Okay.
I
Spark.
Spark.
But there are others. I don't tell you just use Spark. It's just an example. Probably you want to have something which is in scope, fancy. Other questions?
To have 100% coverage is actually minimum which you are supposed to have, because when you have 100, it means that there is still, for example, modifications that were not tested, and only in this case you kind of can guarantee.
Then I will be invited next year and I will have a talk about mutation testing, because what I will tell you right now, sorry about that, is that code coverage is completely bullshit. Okay? Code coverage is the biggest bullshit that was invented by man. The problem is that code coverage is even worse than 0% code coverage, because when you have 0%, you know that you have to be afraid. When you have 100%, you think that you are the king of the world. You can do whatever you want. Your test will fail. Then they won't fail. Then you will ship a bug into production.
Yeah, I think is that the customer still wants to rely on something. He needs the measurements.
So yeah, so it's better not meaningful measurement, not than no measurement problems. That's not a software problem. We are engineers. We are not managers.
Thanks.
Yep.
Sorry.
Yes, since it's recorded, you have to speak into the mic.
Okay, let's say we have several thousands of fake services. So who support it?
That's you. We should support them. That's you should set the fakes during your tests. Set them up, tear them down. It's under your control. It should.
So you're doing everything in the test code? Yes?
Yeah, sure. That's why I advise you to using H2, for example, because you can rely, and it works pretty well. You can rely to everyone having its own Oracle schema. But then what happens if the DBA decide to clean them up and stuff like that? There is a trade-off. That you have to understand that there is a trade-off between I want everything to be the closest possible to the production environment. Then you have to give away control. Then test might fail for reasons that are not related to your code. So you will have false positives. And when it happens regularly, what happens at some time? They are really rejected. The tests are just removed. So again, return over investment, you lost time and money. And the other side of the scope is you have everything under your control. So you have 100% reliability, but the gap between what you did and the production environment is higher. And where you put the cursor is really up to you. It really depends on the context. You just have to know about the trade-off. Other questions? Yeah. I have to find a place where I'm not in the light.
The question is, what is your trade-off for testing stuff like business processes, I mean people's Spring integration and stuff like this?
It never happened to me that I had to test Spring integration stuff. But the thing is, given what I've told you, probably the system under test is very big. So probably what you should do is try to start the process and check the effect of the process, the output. If the output is right, then it's okay. If it's not, then you are in deep trouble. Unless, as I told you previously, you have smaller integration tests along the way. That's the problem if you only have integration test, big integration test. If it fails, you don't know why, you don't know where. But if you have small, then larger and larger and larger tests, then if at some point it fails, you know that the problem doesn't lie in the lower layer, in the lowest system under test.
Okay, I see, but actually the question is, I mean, if you have some business process defined in Beeple, which is, I don't know, about several screens of business process.
When you mean
language.
screen, you mean that there is
Actually,
an interaction with a user?
No, it's not interaction with the user. I mean business process execution language, which is defined with XML.
Okay.
Most times. Actually, you can have a really big business process which calls things like this, that, and probably really some hand user things like somebody should press button to continue
Okay,
this
so
process
there is user interaction with that.
Yeah.
Okay, the problem with user interaction is that it's hard to emulate. So in this case, you will probably have to do stuff like Selenium. And the problem with Selenium is that it uses a user interface. And when you use a user interface, it's the most fragile stuff of all. Because yeah, user interface can change at the whim of any user that say, oh no, this button, I want it into the lower corner instead of the upper corner. It happens all the time. My advice is, again, return over investment. Don't test at this layer, just a little below, test at the controller level. So you would just fake your controller and just put something there.
Okay, thanks.
Other questions? Okay, then thank you very much.